Good afternoon. We are from SRF Limited packaging films business, and our project is building technical capability to produce BOPET films using 90% PCR PET, which is PET bottle crush. BOPET films, as we know, is packaging material which goes to converters for printing, lamination and pouching, and finally goes to brand owners for food and others packaging. So to solve this problem, we are using SRF's 8-step proactive problem solving methodology. My name is Manoj Jain and I am the project lead for this particular project. So where this need is coming from? This need is coming from the fact that SRF had taken an aspiration 2030 to be more socially and environmentally responsible. There were various global industry forums having focus on reduction of virgin plastics, and there were various FMCGs and brand owners looking for sustainable value chain partners, which led us to take this policy goal in FY21 about accelerating sustainability initiatives, under which 4 different themes were identified. While there were other teams working on means like single family structures, product portfolio shifting from industrial to packaging to industrial, we thought of taking 3R as a challenge, and under which we took theme of building technical capability to be able to use 90% of PCR PET. So if you look at the structure of the film, it is a 3-layer structure where 5% on both sides is the skin layer which is with 5% additives, and 90% of the core layer, which is layer B, contains 90% virgin chips, and most of the properties in the film are imparted by this particular layer. And the goal is, how do we replace these virgin chips with PCR PET? So if you see the flow chart of the process, virgin chips are coming from the resin plant. They are mixed with in-process recyclable waste, goes to the extruder. Then there's biaxial stretching in machine direction orientation and transverse direction orienter, and then finally a jumbo of 8.7 meter is produced, which is further slit into various widths as per customer requirement. So the goal is to replace virgin polymer with 90% PCR. So in terms of understanding the requirements, since we already have experience with virgin chips, so we wanted PET bottle crush to be free from contamination, and for quality the target Q is absolutely same as that with the virgin chips, and there, with respect to processability, we don't want any change to happen, and we want a safe, easy to use and operate and maintain the plant. That is the process that we require. So in terms of target Q, same as the virgin chips. Target C, ultimately this has to be a commercial viable project, so that is our target C, that the cost of production should not be more than what it is today. And target D, since we are going to extrude it further, so there cannot be any impact on the filter life, and we want to increase the number of customers with usage of our PET films. So the challenge in front of us was, because this PET crush, as you can see in this picture, is very, very heterogeneous, especially the Indian PET crush, because of the consumer behavior in India. There's a lot of littering happening, and PET crush comes in very, very bad form. So it is washed and then comes to us, but still it contains a lot of contamination. So the processability, and of course this has different bulk density, very low bulk density with respect to the virgin polymer. So that again is a challenge to handle. So with respect to the timelines, we thought that since it is an exploratory kind of project, so this might take 18 months from project conceptualization to execution. So what we did, we explored various alternatives using PDPC. So we thought of converting PET flakes into chips by using mechanical recycling. Since we already have a in-process recycler available with us, so we went to the extent of 6.5 to 15% dosing in March 2020 and tried to produce film out of this. So no issue faced as far as dosage of up to 15% is concerned. So we increased the dosage to 30%. Then we started facing problems with respect to filter choking, color of the film, and low tensile strength. So this made us think that this is not going to be possible with only mechanical recycling. So we have to look for other options. So we thought of chemical recycling, that is the glycolysis route, as the other option. Before I take you to the chemical recycling, I want to inform you that we have a backwardly integrated resin plant where we use PTA and MBG as raw material, and we produce our own chips for film production. So this PTA and MEG, we prepare paste and it goes into multiple reactions like acidification, polymerization, and finally chips cutting. So with respect to the chemical recycling, since we have a continuous polymerizer and a batch polymerizer, so we thought of adding PET crush directly into the resin plant. So since it has low bulk density, so there were black particle generation and very low filter life of resin plant. So this idea was dropped. Second idea was to feed rPET chips, mechanically recycled rPET chips in CP plant, but there was a constraint with respect to the capacity, so only 10% of rPET chips could have been fed. So finally we thought that we will produce chips in batch plant with 100% of PCR PET made chips with mechanical recycling. So that is the idea which was considered for taking it forward. So this is the solution that was adopted. So before ordering a mechanical recycling plant, we carried out a design FMEA with respect to whatever problems we faced in our in-process recycling. We tried to address the problem of filter choking, yellowish color, and of course the velocity. So we took countermeasures with which we came up with an idea of ordering a twin screw extruder with vacuum system and metal separator and duplex filter to address the problems which we faced. By virtue of having our selection criteria, we selected one of the vendors out of 3 to carry out this project for us. And when we selected this, when this machine was ready, we ordered PET crush in China and we took trial with 500 kg of PET crush. We faced problem of off-shade appearance and filter choking there as well, and we had to install pre-sorting unit, NIR sorting, and to remove non-PET and color contamination there. So finally we ordered a sorter and color contamination sorter as well. So finally this project was implemented. A trial with 5 metric ton PET bottle crush was taken at batch plant with 50% and 90% dosing, and then subsequently chemical recycling was carried out, and the film trial was taken. So chemical and physical properties were meeting the expectations. In film line, we faced a challenge of low filter life, so we had to carry out further modifications in the upstream process with respect to changing the filter rating from 60 micron to 30 micron and providing additional preheating station to be able to replenish the filters. So with respect to the in properties verification, so the tensile strength is very well within specs, and without PCR and with PCR. So the process capability we achieved was 1.44. We carried out a film surface comparison as well. So film surface was also found to be very well within the limits. So all the properties are meeting the requirements. Coming to the verification of the larger goal, as you can see, we have improved the number of customers who are seeking aggressively rPET from us. And in routine, it requires only one person to run this plant. The project cost was rupees 38 million, and in fact we although envisage that there cannot be the cost cannot be more than the existing cost, but we are happy to share that this project has actually given us an ROI of 57%. In addition to this, we are very proud to say that we have been able to save on the carbon footprint to the extent of 1,020 tons per annum only in this particular supply chain. So transfer to daily management, since this was a completely new project, so this required establishment of new standards. So we created all the new standards for the new extruder, PET bottle crush recycling testing methods were established. We revised some existing standards with respect to QC/PCs, etc. And coming to reflection with respect to the UN sustainability goal, we feel that goal 12 and goal 9 are the best fit goal that we have been able to service. Goal 12, why? Because it is responsible consumption and production, because we are replacing the virgin raw material with post-consumer recycling. Goal 9, because this is a project in first of its kind project in itself, because nobody else has been able to do it so far, because our film industry is a binary kind of plant, although this finds application in smaller kind of industry like yarn, fiber and others, but we are first one to carry out this particular innovation in film lines. So deployability, since we have carried out this project in polyester, so this can very well be adopted in polypropylene, and it can definitely be deployed in B2B, bottle to bottle concept for PET crush to again bottle manufacturing. And we are able to partner with suppliers. They learn from us, we learn from them, and it has been a breakthrough project in itself, which has led us strengthen our capability in our journey towards sustainability as a responsible manufacturer and help the circular economy in a real way. So as our logo says, SRF, we always find a better way. So we can proudly say that we have found a better way yet again. Thank you so much.